Okay, this is the notes for section 5.5, inverses of matrices. Before you, if you haven't done so already, make sure that you read section 5.5 before going on with these notes. To begin with, let's look at a couple of definitions here. The idea of an inverse operation is something that you've worked with quite a bit throughout most of the time that you've been in math. Inverse operations are operations that undo each other. So addition and subtraction, multiplication and division, squaring, taking the square root. All of these operations undo each other. When that happens, we say they are inverse operations. Okay? Well, we can look at inverses as it pertains to matrices. And now, the only type of matrices that actually have inverses are square matrices. But what we're most interested in is, at least right now, is 2 by 2 matrices. Okay? And 2 by 2 matrices, or most 2 by 2 matrices, have inverses. Okay, and the way that we define that is we say an inverse matrices are inverses of each other if and only if, when we multiply them together, we get the identity matrix. Okay, and the identity matrix, you'll remember, is a matrix for 2 by 2 at least, is the matrix 1, 0, 0, 1. Okay? So when we multiply the two matrices together, if we get that 1, 0, 0, 1, we say they're inverses of each other. Okay? Well, the only type of matrices that have inverses are square matrices. In other words, 2 by 2, 3 by 3, etc. Okay, next I'd like to take a look at the notation that we use for inverse matrices. And what we're going to do is that we're going to, if we write an inverse matrix, we're going to refer to it as m raised to the negative first power. And that idea is consistent with the idea that the inverse of x is x to the negative 1, or 1 over x. Okay? Those two things, x and 1 over x, are multiplicative inverses of each other. In other words, if we multiply them together, we get 1, which is the identity for multiplication, just like 1, 0, 0, 1 is the identity for matrices, for multiplication of matrices. Okay, so we will always use when we're talking about the inverse, we'll name the matrix and then raise it to the negative first power to refer to the inverse of that matrix. Okay, so there's a formula that we can use for finding the inverse of a 2 by 2 matrix. Okay, and what I'm going to do is I'm going to use the inverse matrix theorem, and this is what it says. Okay, if we have a matrix A, B, C, D, we call it matrix M. Okay, and in order for there to be an inverse, we first need to know that AD minus BC cannot be equal to 0. If it's equal to 0, there is no inverse. Okay? And the reason for that is, if you look at our inverse matrix, in each case the bottom number is AD minus BC. So if that value is 0, each of those fractions is going to be undefined, and therefore we'll have an undefined matrix. Okay? So this is the way that we can write that. Now that looks really much more confusing than it actually is, because this bottom number, this AD minus BC, will be the same for all of these. So if AD minus BC is, say, 7, then 7 will be on the bottom of each of these fractions. So it's really about what's going on the top of each of these ones. And you'll notice that the A and D values switch positions, and the B and C values just become the opposite of what they were. Okay, so you're gonna make them fractions with AD minus BC on the bottom. You're gonna change the sign on B and C, and you're gonna switch the position for A and D. So that's the formula that we're gonna use for finding the inverse of any matrix. Okay, so if we look at number 1 here, it says use the inverse matrix theorem to find the inverse of each of these matrices if it exists. So the first one, we have 0, negative 2, 2, 1. So what I'm going to do first, before I do anything, is I'm going to figure out what AD minus BC is. Okay? Because if AD minus BC is equal to 0, I know I don't have a matrix. Well, if I do that on this particular one, I find that AD minus BC is equal to 4. So I go 0 times 1 is 0, minus 2 times negative 2, which is negative 4. 0 minus a negative 4 would be a positive 4. So what that tells me is that that's my bottom number. So I'm going to have a fraction with 4 on the bottom. Okay. Now we're going to be able to reduce that, but that's the fraction that we're going to have on the bottom. So what I'm going to do is I'm going to take each of these values and I'm going to switch A and D. So I'm going to put 1, 0. I'm going to change the sign on B and C. So this one is going to be negative 2 down here. This one's going to be 2. And then I'm going to put each of them over 4. Okay. Now, what I'm going to do then is I'm going to simplify that. Okay, because those fractions can be simplified. And this would be my final answer. So this one stays as 1/4. 2/4 becomes 1/2. Negative 2/4 becomes negative 1/2. And 0 over 4 is just 0. Okay? Now, if I look at part B, if I look at my AD minus BC, well, I have AD would be 2 times negative 10. And BC would be 5 times negative 4. Well, both of those values are negative 20. So when I subtract AD minus BC, it's equal to 0. What that tells me is that there is no inverse for that matrix. So part B, there is no inverse. Okay, the last idea I'd like to take a look at is the idea of determinants and inverses. A determinant is, if you think about our 2x2 matrices, we said that AD minus BC must be any number other than 0, so it cannot be equal to 0. If it is equal to 0, we know that there is no matrix. So because of that we're going to assign that number an actual name. We're going to call it the determinant of that matrix because it determines whether or not we have an inverse. Okay, so we're going to abbreviate that as DET. So if I put DET of matrix M, that's saying the determinant of matrix M. So when I'm looking for the determinant of a matrix, I'm looking for what is the number we get when we take AD minus BC. Now, if it's equal to 0, we know we don't have an inverse. And whatever number it is, if it's not equal to 0, is going to be the number that's going to be on the bottom of that fraction. So it is a number that's fairly important as we look at inverses of matrices. Okay? Okay, the last thing I'd like to do then is I'd like to take a look at example 2 here. It says find the determinant of A if A is negative 3, 5, 7, negative 11. So let's go through and do that. Well, we know the determinant is AD minus BC. So what we're doing is we're finding what that number is. So AD minus BC would be negative 3 times negative 11 minus 7 times 5. Therefore, the determinant of A is equal to 33 minus 35. And therefore, that value would be the number negative 2. So the determinant of A is negative 2.